In this session, we will discuss the structure questions related to topic acid and base and acid, base and salt. So mainly you will find question in which there are reactions of the acid, then the different observation when acid are reacting with different substances, and how we can prepare certain types of salt like soluble and insoluble salt. So the first one, dilute sulfuric acid, is a typical acid. So it's an acid. A student add excess means more than enough, of dilute acid to a copper carbonate. Whenever acid is added to carbonate, any acid is added to carbonate, so the result is the salt, water, and carbon dioxide. So acid plus any carbonate. The result of this reaction, it will give salt, water, and carbon dioxide. So the question is, give 3 observations the student would make. Like what student will observe or what student will see whenever a gas is given off. So whenever any gas given off during a reaction, so we can say bubbles or we can say fizz. We don't have to mention which type of a gas, but we just have to mention what we'll observe. So we can mention bubbles or fizz. And the second thing, a salt is formed, but as a result, as you can see, when sulfuric acid gives sulfate salt, nitric acid gives nitrate salt, and hydrochloric acid gives chloride salt. And here the metal carbonate is copper carbonate. So whenever a copper salt solution is there, so what we'll observe? We'll observe a colored solution, or you can also say blue solution, because copper sulfate is blue in color. So these are the two observations which we will, these are the two things which we'll observe. Number one, we'll observe fizz, bubbles, effervescence. And number two, it will form a colored solution because the copper salt solutions are colored. Then give name of all the products. So what are all the products in this case? As salt, water, and carbon dioxide. So we are getting, so which salt will be there? Because sulfuric acid react with copper carbonate, so it will produce copper sulfate, and water will be there, and carbon dioxide. So these are the 3 products. Because it's a sulfuric acid, so sulfate salt will be there. If it was a nitric acid, then nitrate salt will be there. And if it's a hydrochloric acid, then chloride salt. As in this question, it's a sulfuric acid, so it will produce a sulfate salt. The next question is not directly related. It is acid question, but not directly related to the topic. When a sample of a steel is added to a dilute hydrochloric acid, an aqueous solution of iron 2 chloride is formed. When a sample of a rust is added to dilute hydrochloric acid, a solution of iron 3 chloride, an aqueous sodium hydroxide is added. So when we add sodium hydroxide, if it is iron 2 chloride, what will be the observation with iron 2 chloride? Iron 2 chloride is dirty green precipitate. So here we'll mention dirty green. And if iron 3 is there, we'll observe the red brown precipitate. So dirty green and red brown. If iron 2 is dirty green and iron 3 is red brown precipitate in the presence of sodium hydroxide, and this precipitate does not dissolve or precipitate remain insoluble in excess. In question 4, Potassium iodide and lead nitrate are both soluble salt, and lead iodide is insoluble. Describe how a pure sample of lead iodide could be made from a mixture of solid potassium iodide and solid lead nitrate. So first we have what we have to do. We have to make a salt solution, because to prepare an insoluble salt, we mix the two salt solution. So in one we have, like, solution one is there, and another test tube we have solution two, and we mix them together into another container. When they react with each other, as a result, there will be a formation of a solid, or precipitate will be there. So we have solid, the two salts which are given to us, we have potassium iodide and we have lead nitrate, solid. So first we have to make their solution. So how we can make a solution of these two salts? So first we'll add water. So add water to make solution of potassium iodide and put lead nitrate in two different test tubes. So first we are making a solution by mixing water to this solid, which is solid lead iodide, and another one is solid lead nitrate. Then after addition of the water, what we will do? We will mix the two solution which will form, so because potassium iodide mixed with lead nitrate, so as a result it will form, so mix the two solutions which will form precipitate of potassium lead iodide. Then how we remove this lead iodide from the mixture? Because it is an insoluble salt, so we will use filtration to remove insoluble lead iodide, and then we will wash and dry the solid. So this is what is done. If we want to obtain a insoluble salt from the mixture, so what we do, first we mix the two salt solution, it will form a solid or a precipitate, and that solid or precipitate which we obtain, we can filter it off and then wash and dry. The second part, we want to write an ionic equation for lead iodide or lead 2 iodide. So ionic equation means what are the ions react to form this substance, because if we want to form a lead iodide, a lead iodide is formed, PbI2 is formed. So what are the ions react to form this? So there should be a lead 2 ion, and there should be, iodine belongs to group 7, so iodide ion is -1. And how many iodide ions should be there? There should be 2 iodide ion. So the formula of lead iodide is PbI2. So it means there should be 1 lead ion and 2 iodide ion to form this lead iodide. Is it clear till this point? Then another question. Some oxides of some element are listed. Answer the following question using only oxide, and each oxide may be used once, more than once, or not at all. So different types of oxides are there. Main cause of acid rain, we will only do the part which is related to directly related to this chapter 8, because the one which causes an acid rain, we know it's a sulfur dioxide, acetic oxide is there. So main cause of acid rain, so acid rain is due to sulfur dioxide, which would give a solution of a pH 14, means which one make an which is a basic oxide or make a strong alkali. So if I work out, like example, in a blue shade, if I represent the basic oxide, metal oxides are basic oxides. So sodium will be basic oxide, magnesium will be basic oxide, and the acidic oxide, the non-metal oxides are acidic oxides such as silicon, phosphorus, carbon dioxide, sulfur dioxide, oxide of chlorine. And amphoteric means which can react with both acid and alkali. So this is likely to be an amphoteric oxide. And the only oxide, the neutral oxide, which you have to learn, that is carbon monoxide. So the oxide which will give a basic solution, or means form a base or alkaline solution, that is sodium oxide. Sodium oxide is a metal oxide, that's why it will make a solution alkaline. Which is colored, how to identify the colored, the one which contain a transition element. So chromium oxide likely to be colored because transition element, they have a characteristic that they form a colored compound, so it will be Cr2O3. Major impurity in iron ore, that is in chapter 10, so we'll not do right now, we'll not solve this part. Which is amphoteric. Amphoteric means can react with both acid and alkali. So react with both acid and alkali, that is aluminum oxide. The three examples of amphoteric oxide which you have to learn is aluminum oxide, zinc oxide, and lead oxide. There are more, but you have to learn these three examples only. The neutral oxide, the only neutral oxide which you have to learn is carbon monoxide. That's why CO is the right answer. The next part, in part B, the amphoteric oxide and neutral oxides are different from each other. What is meant by the term amphoteric oxide? What is the meaning of amphoteric oxide? I mean, these oxides are insoluble in water and does not react with acid or alkali. So if you have an acid or you have an alkali, these oxides does not react with acid or they react with acid or alkali. Amphoteric. I thought it was about neutral. So it does react with acid and alkali. What about the neutral? The neutral oxide, they have no reaction with acid or alkali. So insoluble oxides does not react. Insoluble oxides are there, amphoteric oxide, and they do react with acid or alkali. But neutral oxides does not react with acid nor with alkali. Then magnesium sulfate and lead sulfate are examples of the salt. A student prepare magnesium sulfate crystals. So student prepare magnesium sulfate crystals starting with a magnesium carbonate. So the student carried out the 4 steps. First, he took magnesium carbonate to a small volume of sulfuric acid is added. So in the beginning, he's having magnesium carbonate. In the beaker or a container, sulfuric acid is there, or it can be in the conical flask. So there is sulfuric acid present. Now what we do, we add magnesium carbonate. So when magnesium carbonate is added to sulfuric acid, as a result, the salt solution which is formed, the solution will turn into magnesium sulfate. But because we add too much magnesium carbonate, so there will be unreacted magnesium carbonate will be there. Some of the magnesium carbonate does not react. So we are left with magnesium carbonate. So in the question, and whenever acid react with carbonate, so what is the observation? Acid is reacting with carbonate. So as a result, what we'll observe bubbles, fizz, or effervescence because carbon dioxide gas is given off. So how the student knows that reaction completed in step 1? How he can identify that the reaction is completed? So once there is no bubbles, if there are no bubbles are given off, he will be sure that there is no more acid left behind, because if acid was there and still we are adding a carbonate, so there will be bubbles. Name the residue in step 2, like what substance is left unreacted here, the residue or the solid. So the substance which is left here is actually magnesium carbonate. Then a saturated solution is formed. What is meant by a saturated? What is the meaning of saturated solution? Basically a solution which contain maximum amount of dissolved solute at a particular temperature. So a solution which contain maximum amount or greater amount of dissolved solute, like substances dissolve in it at a particular temperature, we call that as soluble solution, saturated solution. The last part explained why magnesium crystals form during step 4. So what happened in step 4? The student allow the hot filtrate to cool down at room temperature, then he removed. So basically what student did, as you can see in the question, the student add an excess of magnesium carbonate, like he add too much magnesium carbonate until the sulfuric acid is used up. Then after that, he carried out the filtration using a filter funnel. So the unreacted magnesium carbonate will left on the filter paper and the solution will pass through. That solution will be magnesium sulfate solution. And using this magnesium sulfate solution, he warmed and then he cooled down so that the crystals will appear for magnesium sulfate. So why the magnesium sulfate crystals form during step 4? What is the reason for that? Basically, the solubility decreases as temperature decrease. Like substance cannot dissolve too much solid or solute at low temperature. So the solubility of the solution decrease, which cause crystallization. When it's a warm solution, it can dissolve more salt, but if it is a cold solution, it can dissolve less amount of salt. That's why if it cannot dissolve too much, then the crystals will appear. Another preparation. So in this topic, there's like lot of salt preparation. If you want to prepare insoluble salt, so what is the technique of preparing insoluble salt is by mixing two salt solution. So lead 2 sulfate is insoluble. Describe how you would prepare a dry sample of lead 2 sulfate crystals starting from lead nitrate and sodium sulfate. So what we will do, because now we in the question we have solution only, so we'll take equal amount of lead nitrate and sodium sulfate solution in two different test tubes. So first we'll take equal amount of lead nitrate and sodium sulfate solution in two different test tubes. Then after taking them in two different test tubes, what we will do? We will mix the two solution which form precipitate, or a solid you can also say, lead sulfate, and then we will filter to remove the solid, and then we will wash and dry. This is always the case whenever you're preparing an insoluble salt. Then these are all the steps. Number one, you take two solutions, you mix them together. As a result, when you mix them together, it will form a solid. This solid is you want to remove. So how you can remove the solid? You can carry out filtration and then wash the solid and dry this. So this will be the desired insoluble salt. Then write ionic equation. So what is the ionic equation for lead sulfate? So we want to produce lead sulfate, PbSO4, and that is a solid because most sulfates are soluble except calcium, barium, and lead. So lead sulfate is insoluble, so solid. So what in ionic equation means what are the ions react to form this? So what will be the ions react to form this lead sulfate? So it contain a lead ion. There is a lead ion and there is a sulfate ion. So the two ions, and ions are always aqueous. So lead ion is aqueous because we have to include a state symbol, how they exist, in which state. So all the ions are aqueous. So lead is aqueous, sulfate is aqueous. When they combine with each other, they will form insoluble lead sulfate. Is it clear discussion? That how we may prepare insoluble salt lead sulfate by mixing the two solutions. Then another question, describe how you would prepare copper 2 nitrate, a sample of copper 2 nitrate in the lab using a nitric acid and copper 2 carbonate. So we have copper carbonate and nitric acid. We want to mix them because basically if you have copper carbonate and you mix with nitric acid, as a result it will produce copper, because nitric acid gives nitrate salt, sulfuric acid gives sulfate salt, and hydrochloric acid gives chloride salt. So as a result, whenever carbonate is there, salt, water, and carbon dioxide. So it will produce copper nitrate plus water plus carbon dioxide. We don't have to write the include a chemical equation. So this is the equation, but equation is included at the last, should be included at the last. So copper carbonate is reacting with nitric acid. As a result, it produces copper. Copper carbonate is reacting with nitric acid. As a result, it produces copper nitrate plus carbon dioxide plus water. That's the product. But how this can be done? How we can prepare this salt? So first, what we do, we'll take a container. I will write the steps, but first I'm explaining the idea. So first we'll take a container, and in this container we'll have a nitric acid. So in the container we have a nitric acid, and to this nitric acid we add a solid copper carbonate. So we'll add a copper carbonate. But how we will know how much copper carbonate is added? So first, when we add copper carbonate, we'll see bubbles. But once no bubbles are formed, all of the copper carbonate, all of the nitric acid reacted, that till that point we'll add this copper carbonate. So when we add too much copper carbonate, unreacted copper carbonate will be left here, and this nitric acid is used up. We are not left with nitric acid. Now the solution actually turn into, so this solution will turn into what? It's turned into copper nitrate. So now it will be the solution of copper nitrate. So first we will filter. Why we filter? Because we want to remove this unreacted copper carbonate. The copper carbonate which does not react, we want to remove that before carrying out a crystallization or evaporation. So first we filter it off. So when we filter off, the copper carbonate will be left on the filter paper, and through the filter paper the solution will pass through, and that is the solution of copper nitrate. So copper carbonate, the unreacted copper carbonate will be there at the top, and below this what we'll have copper nitrate. Now we want to obtain a salt from the solution. So how we can obtain a salt from the solution? So there are two techniques, either mentioned crystallization or evaporation. So how you'll write this? The steps: number one, we will add copper carbonate to nitric acid until no more bubbles, because if no more bubbles, it means all of the acid is used up. So add copper carbonate to nitric acid until no more bubbles. And then what we will do, we will remove unreacted copper carbonate by filtration. Then use crystallization or evaporation to obtain crystals of copper nitrate from solution. Is it clear that how we can obtain pure crystals from this solution, starting with copper carbonate and nitric acid? Any doubt till this point, this discussion? Okay. Just a minute. So in question 9, barium carbonate is insoluble solid. That is in metal topic, the part 1. Suggest a pH of a solution formed when barium oxide is added to water. So if barium oxide or metal oxide is added to water, it means metal oxide will make a solution alkaline. So alkaline solution, they should have a pH more than 7. So you can mention any number. For example, you can mention pH 11, pH 12, any number. Then barium nitrate decompose. Again, that is related to metal topic. So we'll skip third one as well. Now part B, barium sodium carbonate. So again, insoluble salts is there. The preparation of insoluble salt. Aqueous sodium carbonate is added to barium nitrate. Write a chemical equation for reaction between sodium carbonate and aqueous sodium carbonate and aqueous barium nitrate. So sodium carbonate is Na2CO3. How we know the formula? For that you have to recall chapter 2, in which we discuss how to write a chemical formula. So sodium belongs to group 1, so it is +1. And carbonate, the molecular ion, you don't find them in a periodic table, so you have to learn their valency. So carbonate is -2. So for a sodium carbonate, this 2 will come with sodium and 1 will come with carbonate. So the formula for sodium carbonate will be Na2CO3. So we have to write equation. So first we have sodium carbonate, which is Na2CO3. Reacted with what? Reacted with barium nitrate. So what will be the formula of barium nitrate? Barium symbol is Ba. You can use the periodic table. And it belongs to group 2, so it will be +2. And nitrate, NO3, and it is a molecular ion. So you have to learn the valency for nitrate, which is -1. So the formula for barium nitrate, this one will come with barium. You have to learn for carbonate. Whenever it's written carbonate, if you remember chapter 2, there I give you a table to learn, memorize the molecular ion. So carbonate is CO3 with a charge -2. You have to learn or memorize this. So this carbonate ion is -2 and sodium is +1. So we cross multiply. Same thing for barium nitrate. Barium is, you can find barium in a periodic table group 2, but nitrate you don't find in a periodic table. You have to learn its valency -1. So the formula for barium nitrate, it will be BaNO3 bracket 2, because whenever we write a chemical formula we cross multiply the valency. So barium nitrate is BaNO3 in a bracket 2. So barium nitrate is BaNO3 in a bracket 2. Now when two salts are mixed together, this is called a double displacement reaction. Like both reagents take their position, like sodium will take position of the barium and barium will take position of the sodium. So as a result, what will be the product? There will be a product with barium and carbonate. But again, we should write a correct formula. Like what should be the formula when barium is mixed with carbonate? So if the barium is mixed with carbonate, barium is Ba with a charge +2, because, and carbonate is CO3 with a charge -2. Because they have the same valency, so we simplify first. So that is 1:1. And when we cross multiply, so the formula of barium carbonate is BaCO3. Then sodium will come with nitrate. So what will the formula with sodium nitrate? So sodium is +1 and nitrate is -1. When simplify this valency, +1 and -1, so it will be NaNO3. So this is, first we completed the equation. 1 mark is for completing the equation. What about the second mark? Second mark is for balancing. So you can see we have 2 sodium here on the left hand side, but we have only 1 sodium. So to balance, we can only put the number before. We cannot put the number as a subscript or superscript. We can only put the number as a coefficient. So on the left hand side, we have 2 sodium. So we put 2 here. So sodium is balanced. Carbonate is 1 here. Carbonate is 1, is balanced. Barium is also balanced. And what about nitrate? It is 2. But when we put 2, nitrate is also balanced. So this equation is balanced in terms of barium, nitrate, carbonate as well as sodium. Is it clear? Then we want to prepare insoluble salt. So whenever we want to prepare an insoluble salt, so how pure sample of barium carbonate could be obtained? How we can prepare barium carbonate solution? So barium carbonate is an insoluble salt because most carbonates are insoluble except ammonium is there, sodium and potassium. So how whenever insoluble salt is there, it's like mixing the two solutions. So what we will do, we will take equal volume of sodium carbonate and barium nitrate solutions in two different test tubes. So we'll take equal volume of sodium carbonate and barium nitrate in two different test tubes. Then what we will do, we will mix them together, which form solid, or we can also say precipitate of barium carbonate. And how we remove the insoluble salt? So use filtration to remove the salt. And then after filtration, what we do, we will wash and dry the solid. So this is how insoluble salt is prepared by mixing the two salt solution. That is also known as ionic precipitation. Is it clear, this question, that how we obtain insoluble salt, barium carbonate, by mixing the two solutions? For every solution we mix and it turns solid. Not for every solution. Basically, if mixing of the two solution, if a resultant product is insoluble salt, then there will be a solid form. But like example, when we mix sodium carbonate, with barium nitrate, so we know barium carbonate is formed. So barium carbonate is insoluble. So we have to check whether this resultant is insoluble or no. So according to the table, like all nitrates are soluble, most chlorides are soluble except silver, mercury and lead. Most sulfates are also soluble except barium, calcium and lead. And most carbonates are insoluble except potassium, sodium and ammonium. So because barium carbonate is insoluble, so this will result in a formation of a solid. But if for some time what happened, we mix two solution, there is no solid form because there is no insoluble salt produced by mixing of the two solutions. So the salt must be insoluble to prepare by precipitation reaction. Nitric acid is behaving like a typical acid. Some reactions are there but not like in some reaction but not in other reaction. Dilute nitric acid behave like a typical acid when copper oxide and copper carbonate is added. Describe what you see when excess of nitric acid added to copper carbonate. Whenever carbonate is there, acid react with carbonate. So what is the result? The result is salt, water and carbon dioxide. So what we'll see bubbles, and the salt, whenever like copper salts are there, transition element salts are there, so we'll find that it will form colored solution. Because Why colored solution? A salt of copper, salt of iron, salt of nickel. These are transition elements, so their salts are colored, and when they dissolve, they will form a colored solution. But when metal oxide react with acid, what will be the result? As you can see here, when copper carbonate is added to nitric acid, that will give salt, water, and carbon dioxide. So copper carbonate react with nitric acid. What will the result? Result will be copper nitrate plus water plus carbon dioxide. So because this is a product, copper nitrate plus water plus carbon dioxide, and due to the formation of this carbon dioxide, the final result was bubbles, effervescence, and due to the copper salt, because transition element salt, they all are, if they are solution, it will be a colored solution. If it is existing as a solid, it will be a colored solid. So here bubbles and colored solution will be there. But if copper oxide is reacted with nitric acid, so copper oxide plus nitric acid, so what it result? It result in a formation of a copper nitrate plus water, because metal oxide plus acid give salt and water. So this will not produce any bubbles. So what will be the observation here? In this case, it will only form a colored solution. Is it clear? Okay, question 11. The remaining part, reason why I skipped, because not totally related to the topic. So lead to oxide is insoluble. A student add lead to oxide to nitric acid until lead to oxide is in excess. Like what student did, lead to oxide is insoluble, means lead to oxide does not dissolve in water. So what student did, student is having a nitric acid here, and to this nitric acid student add lead oxide. So lead oxide is insoluble in water, but it can react with acid. Lead oxide plus acid, what will be the product? Or nitric acid. So lead oxide plus nitric acid, it's a metal oxide. So whenever a metal oxide is there reacted with acid, the product will be salt. So which salt will be there? It will be lead nitrate plus water. So what is meant by the term excess? Like a student had excess of lead nitrate, lead oxide. So excess means more than enough or too much. So if we add something too much or more than enough, we call that as excess. How would student know that lead oxide is in excess? Like how he can identify that what student was doing, he was adding a lead oxide. When lead oxide was reacting with nitric acid, the solution turned into lead nitrate. But how student knows that he had enough lead oxide? How he can identify? So he can identify when all like solid start to appear, because no more lead oxide dissolve. When no more solid dissolve or a solid appear, it means lead oxide is in excess. So when no more solid dissolve, we will know that enough of lead oxide is added, more than enough is there. Write a chemical equation. So what will be the chemical equation? Lead oxide, so PbO. How we write again? Lead is plus 2, lead 2, and oxygen is minus 2, so we simplify. Lead oxide is PbO. Nitric acid is HNO3. When they react, acid plus metal oxide gives salt, nitrate salt. So lead will take position of hydrogen, so it will form lead nitrate. But you should write a correct formula with valency. So lead is plus 2 and nitrate is minus 1. So when we cross multiply, formula of lead nitrate will be PbNO3 bracket 2 plus water. What is the formula for water? It's H2O. Now equation must be balanced. So you have two nitrate ions. So you should have two nitrate ions. So we put two, nitrate is balanced. We have one lead that is balanced, two hydrogen that is also balanced. So this equation is balanced in terms of all the reagents. Is it clear, discussion? The formation of lead nitrate by reacting lead oxide with nitric acid.